All right. So we're just going over part 2.
Okay. Let me pull mine up real fast.
Okay.
But you guys can go ahead and start. Don't worry about me. I'm just gonna pull it up.
Okay. What did you guys get for number 5?
2.5.
2.5.
Yeah. Okay. Great. And then what about on number 6?
1.12.
Is that what you got? Okay, on this one, I wasn't really sure. The first time I did it, I got like 1.8.
Oh.
Mm.
But I don't know.
How did you do it, Alyssa?
So I made the table like they showed in the reading, and went along and did the column for, what is it? It's the value minus the population mean times the probability, and then it's the square root of the sum of that column.
Okay. That makes sense.
Does anybody else really hate Excel / SPSS?
Yeah.
Yeah. Confusing.
So far, yes.
Okay. I'm not the only one. Okay, good.
No, you're not alone.
Yeah.
Oh.
All right. That makes sense. Okay, so should we go ahead and, because that was all for the homework or the prep, right?
Yeah.
Yeah, that's all that I know of.
Yeah.
Unless there's some mystery new thing that got added, but those are the only 2 questions that I saw.
Okay. So then, should we go ahead and start on the quiz?
Yeah.
Okay, that's fine.
Okay.
All right, I'm going to click on it.
All right. Me too. Is everyone there?
Yes.
On the quiz? Okay. All right. For number 3, the human blood can be classified into one of 4 basic blood types, O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. The blood types and the proportions given in the table above define a probability distribution.
So we're just saying if that whole equation defines the probability distribution, true or false, correct?
Yeah.
Yes.
Yeah, it looks true to me.
Yeah.
Okay.
Yeah, so probability distributions, it says they follow patterns. There are 3 rules that a probability distribution must follow. As long as they follow those, they'll be good. In this course, so the 3 rules are: the probability of an event X is a number between 0 and 1. Rule 2 is if you list all the outcomes of the experiment, such as rolling a die, the probability of one of these outcomes will occur is 1. In other words, the sum of the probabilities of all the possible outcomes of the experiment is 1. And then the complement rule, which is the 3rd rule, is the probability that event X will occur or not occur as 1 minus the probability that that will occur. So based on that, that should mean that it's true, correct?
Yeah. Yep. I think it's good.
I can read number 4.
Okay.
What is the probability that a random selected person in the United States has type O blood? Wouldn't that just be 0.45 because it's given?
Yeah.
Okay, I'll read the next one.
And then 5.
Okay.
Yeah.
Oh.
Go ahead.
Okay. What is the probability that a randomly selected person will not have type O blood? 1 minus 0.45, so 0.55.
Yeah.
That sounds right. Let me just whip out my calculator. That sounds like a correct estimate. Yeah.
Yep.
So let's see. I'll take 6 if that's okay.
All right.
So I have Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to the specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Answer the following questions. If the dog guesses at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient? So, and maybe I just got a little bit confused about the order of everything, but wouldn't that just be the 1 divided by the number of options?
Yeah.
Wouldn't that just be it, right?
Yep.
I'm not overthinking that, right?
Nope.
So that's what I always feel like with these questions. I always feel like I way overthink them way beyond what they really need to. So they have 6 actual samples.
See, there's
So,
there's 7 bowls.
6.
So it's
Oh,
1
7 bowls. That's
7.
correct. Yeah. So divide by. So would that be 0.14, and they said to 3 decimal places, so 0.143.
Yep. That's what I got.
Wait, can you guys explain how did you guys get that again?
Okay, so there's 7 samples total, and they just want the probability that the right one will be chosen the first time, and so it's 1 divided by 7.
Okay.
So it's the ratio of 1 to 7 other samples.
Mm-hmm.
Okay.
Does that make sense?
It does.
All right. Okay, so number 7. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate? There is little evidence that the dogs can detect bladder cancer. This provides strong evidence that dogs can detect bladder cancer. Let's see.
Well,
what did you say that one was?
I think it should be strong evidence because they just said that it's unlikely, it's very unlikely that this would be random.
Okay. It seems like a very deliberate number. I mean...
Well, because what's 22 out of 54?
That's like almost half, I would say.
Well, it's like 40%.
So that's like a 41% chance. So yeah, it should be strong evidence that they can.
I think so.
Should we have her print it off or something?
Well, yeah, she needs to print it off. I can't accept that. It has to be printed off.
Okay.
So.
Well, that's what I figured, but
yeah, as long as she has an actual written script from the doctor, she can bring that in. If
M&Ms
it's
are
not
small chocolate
written
candy.
as a physical form, because we had this big problem with people
website
faxing
previously
things.
indicate that in the U.S. the
When we got that
distribution of the
in,
colors
we had a
in the
lot of
bag
variables of
plain
trying to
M&Ms
figure out what the doctor's
is given
handwriting
in
was and all this other
following
thing. So
table.
unless she prints that off, and that's the only way that we'd be able to accept that.
If you
So,
reach
but
into
if she
the
does that,
back
then that's fine.
and draw candy, so that would just be 0. Can you guys hear me?
Yeah, kind of.
Yeah, we can hear you.
Did you just pull
Yeah.
that ESR off the second, number 2 or number 6?
That was
3,
off of 8.
right?
Off of 8. Sure it was 8.
0.13 versus 8.
It was 8.
It was 8. Because I put one in number 6.
I know, I moved it.
Oh, you did?
Yeah. I restarted it because it wasn't labeled as anybody. And
I
so,
labeled it on the 2, but I wrote number 6 on it.
yeah.
So,
Wait, so what?
Which number?
Well, number 8. Wait, so we already have the distribution. So, isn't it already it's already 0.13, right?
Yeah.
Okay.
That's what we said earlier was if we were talking about the
It was already in
O negative or the
yeah.
blood type, we said it was the 0.45. So if it's not 0.13, then our first answer that we did would be incorrect as well, wouldn't it?
Yeah. Let's see here.
Yeah, all three of them have already reported out. So, let's see.
Sorry guys, I got shut off with my phone. I don't know what went on. Did you guys say that 9 was 0.16?
Yeah.
Okay. Are you guys on 10 now?
Wait, did we say 0.96 or 0.16?
16.
That's what I thought. I'm like putting in my numbers, and I'm like, that is not what I got.
Yeah.
Are we on 10 now?
Yeah.
Yes.
Okay. Would that just be 0.84 then?
Yeah.
Yeah. It would be.
Because you just take 1.
And then minus that percent.
Yeah.
Or that proportion. Alrighty. So I can take a stab at number 11. The ACT scores of students admitted to a medium-sized public university in the western United States were taken from capex.com. The following summary statistics were calculated. Numerical descriptive statistics. The mean was 24.3, standard deviation 4.3, variance 18.6, minimum 14. Quadrant 1 is 22, median is 24, quadrant 3 is 27, the maximum is 35, and the interquartile range is 5. So using the information from the public university to answer the following questions. Half of the observations are less than or equal to what number? Half are less or equal to what number?
Looks like it would just be 24 since that's the median.
That's
Yeah.
what I thought too.
Yeah.
Because that would be our halfway point. It couldn't be anything higher than that because then you wouldn't be in the halfway.
Right. Yep.
So it
Okay.
it has to be 24.
Mhm.
Yep. All right. Number 12. Based on the information on the table above, the top 25% of students scored above what number? So it would be above 27 since that's the Q3.
Yep.
All right.
Wait, top 25, would that be the Q1? Am I understanding this
So
right?
the top 25%.
Oh, yeah, okay.
Yeah.
The Q3,
That would be the third quartile.
Okay, yeah.
75%. So.
Confuse myself. Yeah. Okay.
No, it's okay. I totally overthink these like all the time.
So the top 25 is 27 because 27 is a 75 percentile, right?
Yeah.
Yes.
Okay, yeah, makes sense now. I have to walk myself through it. Okay. Number 13 is which of the following statement is not one of the three rules of probability? So the probability that an outcome will not occur is 1 minus the probability that will occur. That's true, right?
Yep.
Yes. And so is the second one.
The sum of the probability is any probability that is 1, true. If the probability is high, then the probability is positive. That's a negative, but wrong.
Yeah, that's wrong.
And then the last one is probability, yeah, so it would be C, that's wrong. So C is the correct answer.
Yep.
Well, that was easy.
Yep.
Yeah. Not too bad.
Always submit.
Yeah.
I know. I always like squint my eyes like I don't actually want to see the result to see what we actually got.
Yeah.
Part of that whole overthinking it.
Yeah.
100%.
Woohoo! Good job, guys.
Woohoo! Good job.
I think that's it, right?
Yeah, okay, so for our next meeting, so for Abby, it just works for you between like 5:30 and 6:30 on Thursday.
Uh-huh. And it didn't take very long, so we don't even have to stay that long.
Yeah. Does that work for everyone else? Or
5:30 to 6:30 Mountain Time?
yeah.
I can do, gosh, I get off at work at 5:30 Pacific Time.
So that would be 6:30 here.
Yeah.
Okay. What about tomorrow?
I have to work at 7 p.m. So
I work till 5:30 Pacific Time. So
we could just keep it Thursday at 3, and then I'll try to be in as much as I can. Because is that what you guys normally do, is 3 o'clock Tuesdays and Thursdays?
we've been changing it to
Okay.
fit.
Yeah.
Because Tuesdays are fine at 3.
Okay.
I mean, I can really only do it Wednesday or Thursday evening
Okay.
because of my work. Or early in the morning.
Okay.
wait, did you guys decide it's time?
Not yet.
Not yet.
So Macy, what time?
I work at 7 p.m. but I leave here about, I don't know, 5:45 because I work in Idaho Falls, and so
Okay.
it takes me about 4
That other patient for Terry is...
What time in the morning would you guys be able to work or do this?
I can do it probably after 9 a.m. 9 a.m. to 5:45 is when I could do it.
I can do it before 9 a.m. my time. So
Before 9 a.m. your time, on what day? Thursday?
for either Wednesday or Thursday.
Could we maybe do...
We can do Wednesday before 9 a.m.
Okay. That would work because I have class at 9.
Yeah, that should work. Same thing, I'll still be at work, but we can see how it goes, yeah.
Okay.
So it's tomorrow.
So 9:30 Mountain Time.
Wait, so what time are we doing in that?
So wait, 9:30 or 9?
I have to do it before 9 because I have class at 9.
Okay.
So I could do it at like Probably 8.
Is everybody who is on Mountain Time?
Me.
Me.
Who is not on Mountain Time?
I think just me.
Okay.
I'm an hour behind.
Let me think. So of everybody's schedules on Wednesdays and Thursdays, what are the absolute best times so far?
On Wednesday, I can do any time before 5 p.m. And then on Thursday, to 5:45 p.m.
He said he ordered it. I'm just waiting.
No, that one he didn't.
I'm just gonna speak in Mountain Time, so it's
Okay.
easier.
That one was.
Me and my schedules on Wednesday and Thursday are the same. The only time I can't do it is between it's between 10 a.m. to 6:30.
Okay.
That's when I'm after it.
So I think
That's
it would be
kind of
best if we
opposite
just
from-
meet before 9 then.
Yeah.
Would it be okay for us to meet at 8 tomorrow?
Yeah. That would probably work best for me.
Okay.
8 a.m. on Wednesday?
Yeah.
I could probably do that. I would just be kind of listening in, but I probably could do that.
Okay.
Okay. So it's tomorrow, right? Tomorrow at 8 a.m.
Mm-hmm.
Yeah.
And
Okay.
8 a.m. Rexford time, right?
Yep.
Mhm.
Okay. Alrighty.
Okay. See you all then.
Talk to y'all tomorrow.
All right.
Bye.
Bye.